All right, so you probably get the basics of relational databases, right? But how do you go from just knowing about them to becoming a true power user of SQL, especially when you're just staring at a command line? You've got this database file and you want to quickly dig in, ask it some smart questions, maybe even clean it up for efficiency. Well, that's exactly what we're going to tackle in this explainer. So here's the game plan. We're going to start with the super simple stuff, like just peeking inside a database file. And from there, we'll build up step by step until we're designing and querying really efficient, clean databases all on our own. Okay, let's get our hands dirty. You've got a .db file sitting there. What's the very first hurdle? Just figuring out how to look inside it without needing some fancy, complicated program. And the answer is the command line. It all starts right there. The SQLite interface gives you this incredibly direct, powerful way to access the database using these special things called dot commands. And yeah, they're called that because they literally start with a period. So the first question on anyone's mind is always, what am I even working with here? What tables are in this thing? And for that, your go-to tool is the .tables command. And bam, just like that, it lists them all out for you. In our case, you can see we've got one main table to play with, GWASCAT. This one happens to hold a bunch of data from genome-wide association studies. All right, so knowing the table's name is great, but that's just step one. To really understand what's inside it, you've got to see its blueprint, its structure. And that's where .schema comes in. It's absolutely essential. It basically unfolds the map of your table, showing you every single column and what kind of data is supposed to be in it. Now you know what you're dealing with. Okay, so now we know the layout of the land, we can start actually pulling out some data. But let's be real, we rarely want to see millions of rows dumped on our screen. We need to be surgical to find these specific pieces of information that answer our question. And you do that by filtering. The where clause is, without a doubt, your most powerful tool for this. I mean, look at the difference. Without it, you just get a random sample. But with the simple where clause, you can sift through millions of records and pull out the exact one you're looking for. But finding the right data is only half the story, right? You also want to make it look good, make it make sense. You can use order by to sort your results, say from newest to oldest. And what's really cool is you can use built-in functions like substring to chop up and reformat the data as it comes out. It makes everything so much more readable. So filtering is fantastic for zeroing in on individual records. But the real magic happens when we zoom out from looking at single data points and start trying to see the bigger picture, to spot trends. And to see that big picture, you've got to aggregate your data. Functions like count or avg are kind of like magic. They can take thousands, even millions of rows and crunch them down into one single meaningful number. This is the key moment. We're shifting from just looking at a list of records to actually generating insights. Let's make this real. By putting count X together with group by year, we can instantly transform this giant list of individual studies into a super clear year-by-year summary of what's been happening. See? We've just turned a pile of raw data into a story. And a picture is worth 1,000 words, right? This chart just brings that story to life. When you visualize that grouped data, the trend is impossible to miss. You can immediately see this explosive growth in publications. That is the leap from just having data to actually having knowledge. Okay, that's powerful stuff. But what happens when your question is a little more complicated? What if it has multiple parts? Like, what if you first need to count something for each group, and then you need to find the average of all those counts? That, right there, is the perfect job for a subquery. It's really cool. You can literally stick one query inside of another one. The inner query runs first, and its result acts like a brand new temporary table. Then, the outer query runs on that temporary table. It's like building your answer in 2 steps to solve one complex problem. The more we play with this GWASCAT table, a design flaw starts to become really obvious. We're seeing the same information, the same author, the same publication details, repeated over and over and over again. This isn't just messy, it's inefficient, and it brings us to a really core idea in database design. Yup, exactly. This whole problem of repetition is what normalization is all about. It's the whole reason we organize databases a certain way, to structure the data so we can get rid of that redundancy. It saves a ton of space and, more importantly, helps prevent mistakes. So how do we do it? Well, we take that one big clunky table and we split it into smaller, more logical tables. Then we link them back together using these special things called keys. Every row in a table gets its own unique primary key, kind of like a serial number. Then in another table, we can refer back to that row by using a foreign key. That's the link. That's what connects everything. So this means our single, kind of messy Guasquet table is about to get a makeover. And voila, it becomes two clean, super efficient tables. You have one for studies, where each study is listed just once, and then you have a second table for all the ASACs that were found in those studies. They're connected by that study ID, which completely gets rid of all that repeated information we saw before. Okay, so our data is clean, it's efficient, but now it's in two separate places. So the final piece of the puzzle is figuring out how to bring it all back together, so we can ask those really interesting questions that need info from both tables. And we do that with joins. Now, this is a really important distinction. An inner join is strict. It only shows you rows that have a perfect match in both tables. But a left join, that one's a bit more forgiving. It will show you everything from the first table, the left one, even if there isn't a match in the second. This is absolutely critical for asking questions like, hey, show me all the studies we have, even the ones where we haven't logged any associations yet. It's a subtle but super powerful difference. And there you have it. From just poking around a database file to designing an efficient structure and pulling the data back together, you now have the command line toolkit to really master SQLite. Your data is clean, it's connected, and it's ready for you to ask some powerful questions. So the only thing left to ask is, what are you going to discover? If this explainer helped you get there, we'd love it if you'd like and subscribe for more.